Welcome. Today we're going to be covering the Guide to Computer Forensics Investigations. This is the 6th edition. The material all comes from Cengage. They own and control all copyright material. I'm just providing video lectures on the individual chapters for my courses using this textbook. My name is Arthur Salmon, and I'm going to be working with you throughout this book. Thank you. Chapter 10 is about virtual machine forensics, live acquisition, and network forensics. Again, this is just an overview of these core concepts. We're doing a lot of these in our lab videos. So the objectives of this chapter are to explain the standard procedures for conducting the appropriate analysis on VMs, describe the process of live acquisition, explain network intrusion as well as unauthorized access, and we're going to end with describing standard procedures in network forensics as well as network monitoring tools. So first of all, virtual machines or VMs, they're pretty common in business, in personal, in education. They're pretty much everywhere. We need to understand that virtual machines exist, so we have to accommodate for them in our investigation. So we have to have a brief understanding of how VMs function. A VM needs a hypervisor. A hypervisor is what allows the virtual machine to be generated and ran. There are two main types, type 1 and type 2. Type 1 basically will go the hardware, and then the VM is directly on the hardware. They don't need an operating system in between, where a type 2 does. So for example, if you have Windows as your operating system and you install VirtualBox or Virtual PC or VMware's Workstation, those are all type 2 because they sit on top of Windows. Or if you have a Mac variation, VMware Fusion, or a Linux variation, same general process. If there's an operating system between the hardware and the VM, it's a type 2. If the VMs sit directly on top of the hardware, that's typically classified as a type 1. So again, overview. Type 2, these are the ones you're going to find loaded on a suspect's computer almost always. Type 1 are typically loaded on server or high-end workstations with lots of specialized resources, high-end RAM and high-end fast storage. Before installing a type 2 hypervisor, you have to enable virtualization in the BIOS. And that could be things like virtualized technology, the VT, it's an Intel-based process, or the virtual machine extension, VMX. And those are basically the instruction sets created specifically for Intel processors to understand and work with virtual machines. So what are some of the most widely used hypervisors? Again, Parallels for Mac or Windows Fusion, Mac. We'll also use Fusion from VMware. We also have Microsoft's Hyper-V, VMware Workstation or Player, that's for Windows environments. There's a lot of different virtualization hypervisors out there. Here's an example of VMware Workstation. You open up, you give it a name, you give it a location, you give it install files, and you're good to go. This is the most widely used type 2 hypervisor, VirtualBox. And it's free. And again, you get what you pay for. So it may not be the best, but it is what's out there. Other type 2 hypervisors come with templates for different operating systems. Some work better than the others. Some have features that are more feature-rich than others. It just really depends on what you pay for. Again, VirtualBox is one of the more common ones, again, because it's free, but it doesn't have all the same features as you might find in like VMware Workstation. So how do you conduct your investigation when there's a hypervisor there? You begin by acquiring forensics evidence of the forensics image of the source device on the host computer, as well as network logs. By linking the VM's IP address to log files, you can determine if the website that the VM has accessed or if it's from the physical machine or the individual guest machines. Because again, you may have multiple VMs, so you might have multiple guests. To determine whether a VM is on a host device, you need to look for the appropriate VM files. Normally a VDHI or a VD file or a VDMK file. You're going to have to look for specific VMware or VM hard drive files, essentially. They may be in the users or documents, or they may be in a different folder. You're going to have to analyze them. When you're looking at the network settings, if there is an appropriate virtualized network interface, here we're looking at 2 VMware adapters. Well, you know that means there is a Type 2 hypervisor installed on this machine. You can also conduct an investigation by searching for the network adapter, and you'll need to determine whether its USB drives have been attached to the host or not. And again, this could be a live VM running on a system or not, so you'd be analyzing the registry looking at USB logs. A VM can also be nested inside other VMs. You can have a VM hosting inside of a VM, hosted inside of another VM. Nested VMs, they're going to run a little slower, but that is one way to kind of obfuscate what you are doing. Interesting part is you can have a VM inside of a VM. So you can have a Windows physical machine, a host, that's virtualizing a Unix box or a Ubuntu box, and you could be doing your internet searching through your Ubuntu box. That way you can kind of hide your network traffic. Is there a process? Yes, there is. Image the host machine, locate the virtualized software and any information learned, export from the host machine all of the appropriate associated files with that VM, record the hash value, document everything, open the VM as an image file in a forensic software, create a forensics image of the VM, and you treat a VM like a physical machine, and then you analyze it like a physical machine. So that's what we do for VMs. What about live acquisitions? They will include snapshots of the VMs because, again, live acquisition is a running machine. You can snapshot it, and then you can use the snapshot. You're going to record only changes in the state, not the complete backup. And again, you're going to document the entire process. When acquiring the image from a VMware file, snapshots might not be included. So you do need to look at the type of hypervisor you're working with and make that determination. Again, all of that's going to be documented so that you know what you're working with. Doing the live acquisition of the VM is important to make sure snapshots are also incorporated. And again, not all VM tools are going to do that. VMware does do snapshots as part of their acquisition process, but it really depends on the tools you are going to be working with. You can follow the steps in our book to see how to examine a system for evidence of a VM. Other VM examination methods might be looking for like FTK Imager or Magnet or OS Forensics, and you can mount the VMs as external drives. You treat them like a regular physical machine, and you can do your analysis and your image creation that way. You always want to make a copy of the VM forensics image first before you start opening and messing around with it. You want to make sure you're capturing everything possible, and you want to document every step along the way. The nice thing is a forensics investigator can use VMs as forensics tools. Investigators can use VMs to run the tools stored on a flash drive, for example. You can follow the steps in the book on how to prep a VM to run on a flash drive. So what about when you have to work with a Type 1 hypervisor? Again, a Type 1 hypervisor is meant to only run on top of the hardware. So this section is more of an understanding of the Type 1 hypervisors on forensics investigations. Having a good working relationship with the technical people, server and network administrators, can be extremely helpful. Type 1 hypervisors are installed directly on the hardware, and then the VMs sit directly on top of that. Type 1 hypervisors are Microsoft Hyper-V or Zen Server for Citrix, or VMware has vSphere. And then again, there are some Mac variations as well as Linux variations. So live acquisitions are especially useful when you're dealing with active network intrusions. When an actual attack is going on, capturing the data on the fly is critical. Live acquisitions are done before taking systems offline and becoming more necessary. Attacks might leave footprints only in the running process. So the order of volatility is extremely important. And the order of volatility basically outlines what things you should do first. Volatility means that most volatile needs to be captured first. RAM. RAM can be modified fairly quickly, so you need to capture RAM as quickly as possible. So steps for performing a live acquisition: create a bootable forensics disk. Make sure to keep logs and documentation of everything. A network drive is also ideal for placing this information. Copy the physical RAM. Next step varies depending on the incident, but be sure to get a forensics hash of all the files you recovered during the live acquisition. There are several tools for capturing RAM. None of these are what I use. There are Python scripts out there that actually do a really good job at it, but the closest thing would be Kali Linux, but there are some other variations. Again, inside our lab, we will be doing some of these activities. There are some GUI tools also, but they will require a lot more resources. The command line tools give you more control with a lot less overhead. So what do you mean by network forensics? You're going to be capturing the network traffic, processing and collecting and analyzing of raw network data. That way you can track down what's going on over the wire. Intruders leave a trail behind through devices, through infrastructure. So you'd be capturing as much detail as possible to track down what's going on. This can also be extremely helpful in determining whether a network is truly under attack or not. So what does all of this mean? All of this goes back to the need for proper procedure, policies, guidelines, structure. Network forensics is no different. The examiner must establish a very specific standard procedure on how to acquire data after either an attack or a intrusion or a breach or whatever they're going to want to call it, essentially to ensure that all compromised systems have been found. All digital evidence that is necessary for the investigation has been found. So you don't do that during. You do this well before. The procedures must be based on the organizational needs and the complete infrastructure. NIST has a outline guide to integrating forensics techniques into incident response, and that aids in addressing the established procedures. So, moving away from network forensics, how do we actually secure a network? And again, we're talking generalization. Layered approach. You have multiple layers of protection. That way, if an attacker does get in, they have to get through multiple layers to access anything crucial. This is also called defense in depth. It's very similar to what the NSA has pushed, but there are separations of each layer. That includes operational, technology, and people, and each one of these will have their own separate defense in-depth layers. Again, this isn't a one and done. This is a always evolving, always growing area of protection. But that also does include things like testing the network, pen testing, verifying, always recognizing that you need to test, check, test again, check, and it's a circular process. It's not a one and done. You need to also be up to date. That means the OS for all of the infrastructure equipment needs to be updated regularly, and tested and checked regularly. Same thing with key servers, key operating systems, key machines. All of those need to have up-to-date procedures, patches, and they need to be checked. Small companies of fewer than 10 employees often don't consider security as a huge concern. They also do not worry about internal threats. Doesn't matter if that's the case or not, but large businesses, that is a growing concern because they can become more susceptible to problems caused by employees revealing proprietary information, whether it's a large business or a small business. So internal threats are a huge concern. One thing that you have to realize is network forensics is its own specialty. This is just an overview so that you understand that it's not just a component. Also, network forensics is very long, very tedious, and a lot more frustrating than just regular digital forensics focusing on computers. There are standard procedures. Again, always use standard installations, fixing the vulnerabilities after an attack, scan and check for vulnerabilities regularly, attempt to retrieve all volatile data, acquire all compromised digital devices, and compare files on forensics images to the original installation, thus verifying if there's any infections that are spreading. The nice thing is, because you're capturing images, when dealing with a network attack, you can work from images to find most of the files that are needing to be analyzed. You can look for hidden and deleted files and partitions if you capture full images. In the network forensics, you're going to have to restore the drives to understand the overall attack. And that means you're going to have to restore the drives of multiple machines. And then you're going to have to correlate that with logs and other infrastructure logs and traffic. It's just a lot much more in-depth. Again, logs, whether it be from servers, routers, firewall switches, all of that will generate logs you're going to have to then use to analyze. You have TCP dump and Wireshark for examining network traffic, and they can help generate top 10 lists or identified patterns and whatnot. Other tools are like Splunk or Nagios, Spiceworks. Some of these are just brands of tools, not specific tools. Nagios and Splunk have a ton of subtools underneath them, but a lot of what we're looking at here is more of a packet analyzer. Wireshark is an analyzer. You will be using it to monitor and dissect traffic for both layer 2, 3, and layer 4. You can look at and examine the frames, the packets, and the segments using Wireshark or TCP dump. Here we are looking at a TCP header, layer 4 header, and you can analyze this using TCP dump or Wireshark. There are a bunch of tools, Wireshark being probably the most common network forensics tool out there. Here's a photo of Wireshark, and you can use this to analyze network traffic. Here's an example of a captured UDP stream that has content data flowing. When you're investigating a network, keep in mind it can be both virtual or a physical network. Virtual switches are very little difference between a virtual and a physical switch. They both do generally the same thing. Tools for analyzing this is a network miner and Wireshark, and it's not a one or the other. You can use both tools when using them. So we also have what's called a honeypot. If you're afraid that your network might be compromised, you can develop what's called a honeypot, and that is a network that is really a network inside of a network. The honeypot is this enclosed environment that if an attacker does gain access to your network, the goal is to funnel them into the honeypot, and it will look and act like a real network. That way the attacker spends all their time in this fake network collecting fake data. These honeypots allow the company to kind of see where the attacker is going after, how they're doing, and kind of their methodology. It also helps sometimes mitigate things like a denial of service attack. And a DDoS attack doesn't necessarily have to go after a honeypot, but they could be targeting a main router or main piece of infrastructure equipment, or maybe a server. So a DDoS attack is going to use a collection of distributed computers that all target one machine. And the goal here is to overwhelm that one target. That way they can't function. Some other common, oh, it's not changing slides. Some other common types of attacks are things like a zero-day attack. A zero-day attack is an attack that is unknown, and it's really hard to combat it because it's an unknown attack. So only after it's been found or used do people start realizing what it is and kind of how to protect against it. So those are actually really dangerous. And again, a honeypot looks like a regular network luring in a potential attacker. That way you can kind of capture to see what they are doing. A honey wall is monitoring what's happening inside the honey pots. And that is it for this chapter. We talked about VMs, type 1 and type 2 VMs, some of the technologies that have to be enabled in order to get a VM to fully function. We talked about live acquisition, and we talked about acquisition of a VM network. We also looked at steps to take for network defense, layered defense, and defense in depth. We also started looking at variations of network traffic, understanding that you're going to be using tools like Network Miner and Wireshark. And then we're looking at other forms of tools for packet analyzers and honeypots, as well as log tools like Splunk. Then we've kind of wrapped up with the Honeynet project and kind of what its purpose is. If you have any questions or concerns, please let me know. Alright, now that we've wrapped up some of the material for this chapter, are there any questions? There's a lot of different material covered, so again, the key thing is, as you're going through the material, whether it be the reading, whether it be the videos, ask questions, write questions down. The more that you can engage your brain in this material, the better you are at retaining the information. So again, questions, please feel free to reach out and we will go from there. Thank you, and I look forward to working with you throughout the remainder of these modules.